What's up, AgentConf? How's everyone doing? Awesome. Well, my name is Peggy Rayzis, and I am super excited to be here today. When I'm not coding, you can actually find me on the ski slopes. So here's a picture of me last winter from Kicking Horse in British Columbia, and I am super excited for this weekend to hit the slopes with you all. So I'm an open source engineer for Apollo, where I build tools to help bring GraphQL to more teams across the world. And over the past few months, we've been working on a lot of cool stuff that's going to totally change the game for how we manage data in our React applications. And I can't wait to share it with all of you. So let's dive right in. I want you all to just think about how you currently manage data in your production React apps today. So this includes everything from local data, whether it's Boolean flags, results from device API, to server data as well. So if I asked all of you, I'd probably get some different answers. Some of you might say MobX. Some of you might already be using a GraphQL client like Relay or Apollo, but the majority of React developers today are using Redux, and it's around 60% if you look at NPM downloads. So how are we managing data with Redux? And if you've used it before, you know that Redux doesn't support making network requests out of the box. You're probably going to download one of these 3 libraries, and you're going to have to learn their approach to async control flow in Redux before you can fetch any remote data. And if you're using Redux in a production environment, these 2 packages are essential for performance. So first, you have to normalize the data you get back before you store it in your state tree. And then once you want to select the data in your state tree from within your components, you're also going to need to create selectors with reselect to avoid wasted calculations. And that's just the bare minimum. If you need any additional features like optimistic mutations or offline persistence, you're going to have to sort through almost 7,000 Redux middleware packages on NPM. Now, it may sound like I'm picking on Redux here. That's really not the case. I think it's an excellent paradigm that's really changed all of our code for the better by causing us to focus on pure functions and immutable data. But Redux really isn't designed to cover all of the requirements production React applications have when managing data without a lot of manual configuration. And this excess of configuration can really lead to fatigue. It'll have you feeling like this tired puppy up there. And I think within the JavaScript community, I think most of our frustration with configuration, the discussion has really been centered around build tools. But I think the configuration fatigue problem extends to any tooling where our users have to make a choice in order to execute a core feature. And I think this configuration fatigue is really a huge issue in our community today. It not only results in wasted hours tinkering with setup instead of building your product, but perhaps the most troubling consequence of all is that it discourages newcomers from learning and prevents them from being productive with React quickly. So I think we can help ease the pain of configuration fatigue by guiding the community toward cohesion. And I think this is a little bit challenging for the React ecosystem as we've never had a cohesive story for managing our data, even after 5 years. So, okay, this term is like pretty vague. What exactly do I mean by cohesive data story? So if we can generally agree upon how we should handle these core features, we'll inch closer to the dream of an ideal data layer for React apps. So here are some features that you really shouldn't have to configure. You should be getting these out of the box. So declarative data fetching. Ideally, we should be able to receive data in a way that maps cleanly to the props that our React components expect. Optimistic mutations are a given for making users perceive your app as performant. And this really should be trivial to execute. This should be something that you can do quickly. Async control flow should just work right out of the box. You shouldn't have to learn 3 libraries just to make your first network request. combining local and server data is really an interesting one. So your components are probably made up of many data sources. They're probably not all remote data or not all local data. So there's really no reason why you shouldn't be able to easily combine these data sources. And I think finally, a great developer experience complete with dev tools for easy debugging is also a must. So I didn't just make this criteria up myself. I got it from Dan's talk 2 years at React Europe, and I think it's a pretty accurate way to evaluate a data management solution. And I think since that talk, many libraries have come close, but none have been able to offer all of these features out of the box just yet. It turns out that GraphQL is a great solution for incorporating many of these features, which is what we're going to learn today. So, quick show of hands, who here has used GraphQL before? Okay, so a couple of you. Let's just do a quick refresher on what GraphQL is. So it's a query language developed by Facebook that allows you to describe your data requirements in a declarative way. And that's kind of a mouthful, so let's use an example to illustrate that. So let's pretend we're hungry for a sandwich. Now, I hate to do this example right before lunch, but it's all I got, so just bear with me. So using GraphQL is kind of like ordering a sandwich in a restaurant. So to ask your waiter for the sandwich, you're going to use an operation called a query. And you can be very specific about what is and isn't on your sandwich, and you do this by specifying fields. So pretty much everything up there, like bread, baguette, those are all examples of fields. If you don't know what to order, you can browse all of the available options to you via the schema. So you can think of the schema as kind of like your menu. And when your sandwich arrives, it will be in exactly the same shape as how you ordered it. No more or no less ingredients. In contrast, REST requires a lot more manual work. So with REST, you first have to know where all of your bread, your toppings, and your meat exist, and you have to call your endpoints to get all of the ingredients. And once you have them, you then have to filter them down in order to isolate the ingredients that you want. And on top of that, once you have your desired ingredients, you have to combine them into the sandwich itself. So if we're at a restaurant, GraphQL is like ordering your sandwich from a waiter. REST is kind of like going back into the kitchen and making the sandwich yourself. But personally, I'd rather have the first option. I think the second is a little too error-prone. And with GraphQL, you're always guaranteed to get back exactly what you ordered. So wouldn't it be awesome if we could delegate ordering the sandwich to something else? We need a way to handle sending out our order and also delivering our sandwich to us. And that's where Apollo comes in. So you're looking here at a preview of our new API for React Apollo featuring a query component with render props, because that is super trendy right now. So yeah, enough with the sandwich metaphor. Let's learn about what Apollo is and how it can simplify data management in our React apps. So if you've heard of Apollo before, your first thought is probably a GraphQL client. And I think while that may have been true last year, it's really selling it short. I think Apollo is so much more than just a client that requests and receives GraphQL data from a server. Apollo is actually the first cohesive data story that React has ever seen. And that's a pretty bold claim. I'm going to try to back that up. But really, this is all thanks to the power of GraphQL. So over the past year, we were already solving all of these problems without even knowing it. And I think a lot of this is thanks to the nature of GraphQL. As we saw before, GraphQL data maps really nicely to props in our React components. Apollo Client has built-in optimistic UI without you having to configure anything. You just get that right out the box. Resolvers offer a unified API for performing async side effects on both the client and the server, again, without you having to set this up yourself. And now with our state link that allows you to manage local data with Apollo Client, we can combine client and server data in one query. We also have excellent dev tools that help you understand what's happening with your GraphQL data underneath the hood. So I think all of these wins have really resulted in tremendous growth for the project, more than 350% last year, according to NPM's research. And companies ranging in size from startups to enterprises like the New York Times and Ticketmaster have started using Apollo in production. And all of this is really setting up for 2018 to be a breakout year for Apollo. I think one of the reasons why we've been able to drive adoption so quickly is our low barrier of entry to getting started and feeling productive with Apollo Client. In only 6 lines of code, our default setup will give you caching, optimistic UI, data fetching, and more without you having to configure it yourself. There is a little magic that goes on behind the scenes here to create these sensible defaults. So let's dive into the internals of Apollo Client. The client itself is really just a thin orchestration wrapper over the Apollo cache and your link chain, which is your network stack. And both are customizable if you need to layer on additional features. So let's start with the Apollo cache. The Apollo cache is awesome because it normalizes and stores your data for you. You don't have to mess around with the normalizer or set any of this up yourself, just 0 configuration right out the box. And that's a really good thing because it turns out caching GraphQL data is, to quote my buddy Ken Wheeler, it's real fucking rowdy. So like, why do we need to normalize our data? Why do we need to cache it? This seems like a lot of work. Normalization is important because there are often multiple paths to access the same data with GraphQL. So here we have a sample UI with an article feed and then also an editor detail view. So we have a query to get all the articles for our feed. Now, let's say we want to make a change to the article's title over on the detail view with the update article mutation up top. So ideally, once we fire off this mutation and get the result back, we want the data on the article's feed page to update with the new title as well. Keeping your data consistent and in sync is exactly why we normalize. So you understand what's going on under the hood. I'm going to try and demystify the Apollo cache's normalization process for you. So first we have our articles query. You'll also see we have the response payload, which is exactly in the shape of the query, with the addition of one field. And hopefully you can see that in the back. That one field at the bottom is actually a meta field. It's called type name. And it's added automatically for you when the data comes back from the server. So for each nested part of the query with a type name and an ID, we split out those results into their own nodes in the cache in a flattened map, as you can see there. The cache key for each node is the type name plus the ID. And if you don't have an ID or a type name, the cache key will come out as null, so it won't be split out into its own separate entity. So then for the articles query, we can see that the cache value is a list of pointers. And this is because when you get back the result from the query, the cache will actually reconstruct each result from the flattened nodes in the cache. So don't worry if this sounds a little complicated. You can actually fully inspect your store in Apollo DevTools to see what's going on. So here you have a detailed store view, and on the left you can click to explore all of the nodes in the cache. So as we discussed earlier, Apollo Client is made up of both the cache and your Apollo link chain. You can think of your link chain as your network stack that manages the request and response cycles. So here's an example illustrating a common link chain for an Apollo app. Links are composable. They return observables and can either forward the operation along the chain or they return a result. And since you can hook in at any point in the cycle, links can be either middleware or afterware too. You can also intercept the request before it hits the server and send back a result, which is what we're doing here with our state link. So with its awesome out-of-the-box experience, Apollo Client is simple to get started and already includes a lot of core features just by using the defaults that we saw earlier. However, if you're a more advanced user and you have more specific use cases, it's also extremely extensible. A great example of this is Apollo Cache Persist, a package that allows you to persist your cache to any kind of offline storage. So here in this example, we're using React Native async storage and persisting the cache when the app is in the background. You can also persist on every cache write or set up your own trigger if you desire. So I just want to give a shout out to one of our amazing community members, James Reggio, for his awesome work on his package. He actually wrote it for his React Native app, Banter FM, and then worked with our team to open source it, and it's been a huge win for the community. since Apollo links allow you to hook into the request cycle at any point, you can start to get really creative with how you use them. So here are just a few links our community members have built to add new features to Apollo, like the ability to query a web worker using GraphQL. Perhaps the most creative applications of links yet is our newest release, Apollo Links State, which allows you to manage your local data with Apollo Client and query it with GraphQL. Link State is truly pushing the boundaries outside of GraphQL, outside the context of the server, which is normally how it's been done up until this point. So let's see how we got here. I think for you to understand just how noteworthy Apollo Link State is, we first have to look at Apollo's past. So historically, users put all of their remote data into Apollo Client. And this equated to about 80% of their data. But what happens for the other 20% for things like Boolean flags or device API results? So for that local data, users maintained a separate Redux store, which they were not able to query with GraphQL. And keeping this store in sync and managing these different interfaces to their data became tricky, especially as Apollo Client 2.0 moved off of Redux. Today, with StateLink, we now have the ability to query all of our application's local and remote data with GraphQL. And this has several advantages. First, GraphQL becomes a unified interface for how we communicate with our data. And since React only knows about Apollo Client, theoretically, we can add multiple data sources to that link chain. So here we have StateLink and an HTTP link, but then you could add on maybe an Apollo link to query a web worker and be able to get all of that data with GraphQL. And also, the Apollo cache becomes our single source of truth. No more managing a separate store and having to sync up the data yourself. Now you can manage your local data the same way you manage your remote data. So here's how you set up a simple client-side resolver with StateLink. So first, StateLink is going to receive any defaults that you would like to write to the cache upon initialization, and you can think of that as your initial state. And then you actually pass in the Apollo cache itself. You're also going to need to pass in a resolver map. So if you've worked with GraphQL tools in the server, this API is going to seem very familiar. You get the root, you get any arguments, and then you also get the context. The only difference here between the client API and the server API is that the cache is automatically added to the context for you, so you can read and write data to it. Mutations can either return null, since all GraphQL types are nullable by default, or they can return data that then you can use in your UI. So let's dive a little deeper into some of the fundamental concepts of Apollo and how it relates to what you're currently doing in Redux. Apollo Client 1.0 was actually built on top of Redux, so you can find a lot of common threads between the two. So with Redux, you had the concept of a state tree. With Apollo, you have the concept of a data graph. Now, I know a tree is just really a more specific graph, but bear with me here. The Apollo cache is really represents your normalized data graph. And with GraphQL, you can think of all of your application's data as a big graph with multiple paths to access the same data, just like we saw earlier in the normalization example. A huge advantage of GraphQL is that you no longer have to write your own selectors with reselect. GraphQL queries and mutations become the standardized way to select and interact with your data. Due to the normalization process, this makes it easy to attach a client-only property to server data while still maintaining separate entities in the cache. And we're going to see an example of how to accomplish this soon. So in Redux, you had actions. With Apollo, you have queries and mutations. So I think we've all been here before, right? In order to execute one network request in Redux, you have to keep track of at least 3 actions, one for loading state, one for errors, and then one for finally the result. But why write all of that boilerplate when you can just write one query to do the exact same job? Aside from that, aside from reducing kind of the boilerplate that you're going to have to write, GraphQL is also a very declarative way to describe state changes in your application. So in order to fetch that query's data that we just saw, we first need to bind it to our React component. So from there, Apollo Client actually keeps track of loading and error state for us. So we don't have to manage that ourselves. And then once the result returns, we'll automatically get the data back on our data prop. And that's really all there is to it. It's super easy to just fire off that query and then bind the data to your component with React Apollo. And if you want to get even more granular, Apollo Client can actually track multiple different kinds of loading states. So for example, like what do you do if you're refetching a query, but there's already data on the page? The network status will inform you of every status change along the way, so you can update your UI appropriately. So with Redux, you're probably used to writing reducers and action creators. With Apollo, resolvers kind of take the place of both action creators and reducers because they both return state and they also perform side effects. So the API that you use to create resolvers on the server is the exact same API that you use to create resolvers on the client with link state. Another cool feature is that async resolvers are supported out of the box. So you can query asynchronous device APIs on the client without having to set up a complicated control flow like sagas, for example. You can return values from mutations as well, but you don't have to. This can be really useful if you're creating a to-do, for example, and you want to get back the new to-do's ID. You just return that new to-do in the mutation, and then you can query for the fields that you want. So here's what this looks like on the client. When you manage state in Apollo, your Apollo cache becomes your single source of truth. So let's break down what's happening here. We have this toggle to-do mutation, and it receives the arguments, the root value, any arguments to the mutation, and then also the cache on the context. So first, in order to access the to-do item and toggle its state, we first need the value that's already in the cache. So we use that cache key, that type name plus ID that I was talking about earlier, to grab that fragment from the cache. Once we read that fragment, we can then look at the data and then toggle the completed state of the to-do. Once we do that, we can then write the new data to the cache. And by passing in the cache key as the ID to write data, you can actually write to an existing object in the cache, as opposed to just passing in data, which writes it to the root. So this is a huge advantage to using GraphQL. GraphQL actually doesn't really care about where you get your data from. So this allows us to use directives to combine local and server data in one query. When we trigger a mutation from our UI, Apollo's network stack needs to know whether to update the data on the client or the server. So in order to do that, we have this client directive, as you can see on the isSelected field, to specify client-only fields. So then Apollo link state will actually split up the query, send those remote fields to the server, and then calls the resolver for the client-only field. And we can use this to append client-only data to our server data just by writing a resolver for list is selected. I really love this quote from Scott Tolinsky about switching to link state. He just did a really great episode of Syntax FM. It's a podcast with Wes Boss where they talked about their first impressions migrating to link state. I'm going to be posting links to all the references I discussed today in my talk on GitHub, so be sure to check it out. I'd also like to point out that Sarah Vieira, who's speaking tomorrow, recorded an excellent video tutorial on Apollo link state. I'll also be sending the link to that as well so you can kind of see it in action and get a feel for it yourself. So our goal at Apollo is to make GraphQL easy to use and accessible to everyone. A common misconception is that you really need a GraphQL server in order to take advantage of Apollo. And up until recently, this was true. But in order to help more people get started with GraphQL faster, we worked with our awesome community members, Victor and Frederick, to release Apollo Link REST. And what Apollo Link REST allows you to do is query your REST endpoints with GraphQL without having to set up a GraphQL server yourself. And this is really great for front-end teams that don't control their back-end or for people who just want to experiment with GraphQL before committing to building a server. It works very similarly to state link. So instead of a client directive, you have a REST directive, which allows you to pass in the path and then the name of the type. Our hope is that you eventually build a GraphQL server of your own in order to take advantage of GraphQL's benefits beyond the ease of querying. When you're using a GraphQL server, it's much easier to share code across teams because you're not duplicating the effort in every client-side application. You also have the benefit of smaller payloads since GraphQL gives you back only the fields that you asked for. And you'll also be able to take advantage of all the latest features coming to GraphQL servers, things like persisted queries and also cache control. So let's talk about what's next. I am super excited to share with you some of the more experimental things we're working on. So who's ready? I need a little enthusiasm here, otherwise I'm not going to show you. So you probably noticed I didn't mention client-side schemas at all when talking about state link. And that's because they're a really tricky problem to solve. Since the GraphQL JS modules for validating a schema are extremely large, we can't just include them the way that we would on the server. So just this week, we actually got a working prototype of the client-side schema working. While the schema doesn't perform type validation, it does allow you to write a schema and schema definition language and perform introspection against this AST. And introspection is really something that's kind of unique to GraphQL. If you've never used it before, there's a really great tool called Graphical, which generates automatic documentation for your schema and allows you to interactively explore it. So if we can perform introspection against a client-side schema, then we can actually integrate our client-side schema into our tooling. So my coworker, James Baxley, has been really hard at work with improvements to the Apollo DevTools. And just yesterday, we got a working prototype of client-side schema introspection stitched alongside our remote schema. So this may not look like a lot, but this is actually really huge because now you can inspect your remote APIs alongside your client-side data without ever having to leave the DevTools. And this also brings along a whole host of other features, such as autocomplete when running queries in Graphical, and the ability to perform tracing analysis on both our client and remote data. So right now this feature is in alpha, but we're hoping to release it very soon within the next couple weeks so you all can start exploring with it. And I think it brings along a lot of really interesting possibilities. If we can stitch together a client schema with our remote schema, we can stitch together anything. So imagine being able to explore your Gatsby schema for static data alongside your dynamic client data. GraphQL truly becomes a one unified interface for accessing all of the data that flows within your application. Now that we have the ability to stitch together the schemas for multiple data sources, we'll be able to integrate introspection into a variety of different tools. The most obvious case here is DevTools, like what we just looked at, but we also have a VS Code plugin in the works that will feature autocomplete as you're typing out the queries into your editor. We can also integrate our client-side schemas into Apollo Engine to analyze performance and tracing data. With GraphQL as our unified interface to all of our data, our tooling suddenly becomes more cohesive and unified across the stack. And now, this is not only great for developer productivity, but it is the key to reducing configuration fatigue. With GraphQL, you can teach someone how to build a resolver once, and they'll automatically be able to apply their knowledge across the stack for both local and remote data. Now, this is all really fresh and new, but I think we're really on the cusp here of something super exciting that's revolutionizing how we interact with data in our React apps. And I can't wait to see what the future holds. Thanks so much, and see you on the slopes, everyone.